Hi students, how are you? This is Madhvi Madam Chemistry. So today I want to discuss about senior chemistry IP long answers questions from electrochemistry and chemical kinetics. So here in the senior chemistry, three chapters are very important for 8 mark questions. Regularly, repeatedly, they are asking from these three lessons. One is electrochemistry and chemical kinetics, and another one is P block elements, and third one is organic chemistry. Third one is organic chemistry. So from electrochemistry and chemical kinetics, easily we will get the 8 mark questions. So from these lessons, surely three 8 mark questions will come. In these three 8 mark questions, we need to write two only. One is choice question, and this year 2025-26, they increase the marks. Up to last year, we written chemistry for 60 marks paper, but this year we are writing for 85 marks. They are introducing 1 mark multiple choice questions from this year 2026. Okay, so let us start. I will explain the sure gunshot 8 mark questions a very easy, simple and easy way. So from the electrochemistry and chemical kinetics, today I will explain the 8 mark questions from electrochemistry. So let us see that. Question number 1: state and explain Kohlrausch's law of independent migration of ions. State and explain Kohlrausch's law of independent migration of ions. Okay, this is repeatedly asking questions every year in AP. Telangana, some years they asked. So previously in Telangana state they asked in 2016 and 2023. In AP regularly 2015, 2016, 19, 22, 23, 24. Again supply 24, 25. Nearly 8 years, 8 consecutive years, they are asking this. State and explain Kohlrausch's law of independent migration of ants. So this is very simple and easy. So if you learn this question, surely out of 8 marks you will get. This is first. We are divided into points wise like this. So in this Kohlrausch's law, first definition will write. After that, what is the formula of this Kohlrausch law will write. After that, example of this Kohlrausch law will write. And what are the applications of this Kohlrausch law we can write. Like this, if you present means you'll get 8 out of 8 in the theory exam, intermediate public examinations in senior interchemistry. Okay, so let us see what is the definition of Kohlrausch law. What is the definition of Kohlrausch law? Okay, so definition of Kohlrausch law is nothing but the limiting molar conductivity lambda naught m. The limiting molar conductivity lambda naught m of an electrolyte is equal to the sum of the limiting molar conductivities of the cations and anions. Cations limiting molar conductivity lambda naught plus, and anions limiting molar conductivity lambda naught minus of the electrolyte at infinite dilution. At infinite dilution is called Kohlrausch law. What is Kohlrausch law? Once again, the definition: the limiting molar conductivity lambda naught m of an electrolyte is equals to sum of the limiting molar conductivities of cations and anions of the electrolyte at infinite dilution is called Kohlrausch law. Okay, so now we learn the definition. Let us go for formula. So now only we said that the limiting molar conductivity lambda naught m is equals to sum of the limiting molar conductivities of cation plus anion, lambda naught plus lambda naught minus. So lambda naught m is equals to lambda naught plus lambda naught minus. So if you know this formula, we can easily write the definition: the limiting molar conductivity. Okay, the limiting molar conductivity lambda naught m of an electrolyte is equals to sum of the limiting molar conductivities of cation plus anion minus. So this is the formula for Kohlrausch law. Let us take one example. Example for the electrolyte NaCl. So we are taking as NaCl example. If you write the Kohlrausch law for this electrolyte NaCl, we have lambda naught NaCl is equals to lambda naught Na plus plus lambda naught Cl minus. So what is the definition of Kohlrausch law? The limiting molar conductivity of NaCl is equals to sum of the limiting molar conductivities of Na plus plus Cl minus. So this is example of Kohlrausch law. So then this is the definition, formula and example. Just fourth point, applications of Kohlrausch law. What is that, ma? Applications of Kohlrausch law. Kohlrausch's law is used to calculate the following. So by using Kohlrausch law, we can calculate the following. One is limiting molar conductivities of weak electrolyte. We can calculate the limiting molar conductivities of weak electrolyte. We have to take weak electrolyte, not strong electrolyte. Who are weak electrolyte means they will produce less ions in aqueous solutions. So for example, CH3COOH, NH4OH, like that. Those are called as weak electrolytes. So by using Kohlrausch law, we can calculate the limiting molar conductivities of weak electrolytes. First point. And second point, we can calculate the degree of dissociation alpha. Degree of dissociation of weak electrolytes. That is alpha is equals to lambda m by lambda naught m. Alpha is equals to lambda m by lambda naught m. This is called alpha is nothing but degree of dissociation. So we can calculate the degree of dissociation of weak electrolytes also by using Kohlrausch law. And next, the third one, we can calculate the dissociation constant, that is K. We can calculate the dissociation constant K of weak electrolytes. So here dissociation constant K is equals to C alpha square by 1 minus alpha. Alpha is nothing but a degree of dissociation and C is nothing but concentration. K is nothing but dissociation constant. So this is the brief explanation of Kohlrausch law. Okay, so here in Kohlrausch law, majorly we see that definition, formula, example, applications. Okay, if you know the formula, we automatically write the definition. Okay, limiting molar conductivity of an electrolyte is equals to sum of the limiting molar conductivities of cation plus anion. Okay, at infinite dilution is called Kohlrausch law. Example, lambda naught m is equals to formula lambda naught plus plus lambda naught minus. Example, we are taking NaCl. Lambda naught NaCl is equals to lambda naught Na plus plus lambda naught Cl minus. So what are the applications means? We can calculate the limiting molar conductivities of weak electrolyte. We can calculate the degree of dissociation of weak electrolyte. We can calculate the dissociation constant of a weak electrolyte. So I hope you understand this very important 8 mark question. Today only you have to complete this 8 mark question. Then you'll get 8 marks in your account in 2026 IPE Senior Inter Chemistry. I hope you understand this video. Please like, subscribe and share my video. Thank you all members.